Okay, boys, just wanted to start by having a quick look at the introduction text on the bending stress, shear force diagrams and the bending moment diagrams. So just straight out of your book, this is what you should be doing this week. Bending stress, a stress that is induced at a point on a body subjected to loads that cause it to bend. You can see a diagram of a fixed point and block setup. So when a load comes down and bends the beam in that shape, we get compressive stresses on the top and tensile on the bottom. And when it's in the opposite, the compression and tension swap around. So be aware of that. When a beam has loads acting on it, shear force and bending moments can be calculated. Definition of shear force is the force in the beam acting perpendicular to its longitudinal axis. So that's it there, longitudinal axis. In most cases, the maximum value of shear occurs at the supports. And then a definition of shear force diagram represents the sum of the shear force reactions that act at given points along the beam in response to externally applied loads. And there you've got an example of a beam with some loads on it. We'll be kind of used to, we can work out the reactions, and this is what we will be doing. Completing a shear force diagram. It's going to look something like that, but we'll get there shortly. So our bending moment then is the reaction induced in a structural member caused by an external force acting perpendicular to the member, resulting in a bend in the beam. Okay, same as what we've seen before. A couple of points of terminology there: a sagging moment and a hogging moment. Sagging moment when the force is coming from above and pushing down, and a hogging moment when the force is pushing up from underneath. You get the concave and convex. So a bending moment diagram represents the sum of the moments acting in a given point along the beam. And here again is the example of our simply supported beam. We can work out the reactions, and we can then create a bending moment diagram from the beam above. And we can read there, both the shear force and bending moment are essential for the analysis of design of structural members. When choosing an appropriate material, it is necessary to check the member for shear force and bending moments so as to withstand these forces. This is vital to avoid failure of structural members. So you can see this would be a very, very important part of an engineer's work. Let's have a look over the page where we've got an example. Hopefully you've read this previously. So there we've got a basic example, simply supported beam, got a roller support, we know that that reaction is only perpendicular, and a pin support, we can get different reactions there, 40 kilonewtons and 90 kilonewtons coming down. So step one, calculate the reaction forces at A and B, and by using our sum of our moments, we can find that A is 50 kilonewtons going up there, and B is 80 kilonewtons going up there. So I can just draw that in to say 50 kilonewtons and 80 kilonewtons. Where they're the reactions we're looking for. So that's that part done. Found the reaction, step one. Step two, start the shear force diagram at the first value of the force acting on the beam, which is in this case is 50 kilonewtons due to the reaction at support. So I suppose one of the first things we have to do, guys, is set up some sort of table. Now, if you're doing that on Word, it's very simple to just pop in a table and adjust the amount of columns that you're happy with and the scale that you're using. You can do a table and not use all the columns, that's fine, or you can sketch one up yourself. So here you can see along the x-axis we've got the distance in meters, and then the shear force in kilonewtons. Now these scales are independent of each other. They don't have to be equal or anything like that, so don't get too concerned there. So we're starting at the 0 point along the axis, and we're moving up for our 50 kilonewtons. Sorry, our 50 kilonewtons there. We are moving straight up to 50 kilonewtons. Our next force is 40 coming down, and it's at the 2 meter mark. So that's why we've gone straight across until we've hit the 2 meter mark, and we're coming down for 40. Okay, and we stop. The next force is the 90 force, and it's at the 8 meter mark. So if we have a look at that, 2, 4, 6, 8 meters. Okay, we've traveled straight across until we hit that 8 meter mark, and then we're going down again. Okay, that's to -80, but it's a distance of 90 kilonewtons. Okay, because we've started there, we've gone down to -80 there, but there's 10 there, so that's the 90 kilonewtons going down there. The last one is the 80 kilonewton reaction that we're going to. It's another 2 meters along, so we travel 2 meters straight across and then back up to 0. We always know we have to finish on 0. So that's an example of our shear force diagram.